Hello everyone, I am Yusril Marenta. Together with my groups is Nara Kaludan and Ernest Dave de los Reyes. And today we're delving into the world of sorting algorithms. Our focus, the dynamic duo of sorting, heap sort and insertion sort. These are two powerful algorithms used to arrange data efficiently. Heap sort, it involves building a heap from the elements to be sorted and then repeatedly removing the maximum elements from the heap and reconstructing the heap until it's sorted. Insertion sort, it builds the final sorted array one element at a time by repeatedly picking an element from the unsorted part of the array and inserting it into its correct positions and the sorted part. Interesting points or highlights about heap sort and insertion. Heap sort efficiently handles large datasets with its time complexity while performing in-place sorting. While insertion sort adapts well to nearly sorted arrays, maintains stability, and is capable of real-time sorting data arrives incrementally. Now, we all know the short definitions of heap sort and insertion sort. To fully understand what is heap sort insertions, let's proceed to the next video.
Good day, it's me, Isnara Kaludan, and in this video, we're gonna give a learning about how we could insert data within our heap. So to get started, let me explain first the two steps that we should consider whenever we insert our data. First step is always insert at the last available position. And the second step depends on whether or not our heap is a minimum heap or a maximum heap. If at the minimum heap, we compare data that we just inserted to its parent data. If it's smaller than its parent, we swap. Continue to do this until we reach the root node. If it's not smaller than its parent, we know that this is the right spot for the data to be. We do this until we reach the root node. If it's maximum heap, we just do the opposite. We compare the data we just inserted to its parent. If it's greater than the parent, we swap. If it's not, we know that this is the right place for your data to be inserted at. And once again, we keep doing this until we reach our root node. Alright, so let's proceed to our example of minimum heap. As you can see above, we have already an index, which is 0, 1, 2, 3, 4, and 5. And also, we have an input data, which is 9, 2, 7, 3, 6, and 5. So given the following data, let's insert it into our heap. So, start with a 9. Since our heap is empty, this becomes the root and node. So we insert an index 0. Moving on, let's insert 2. 2 gets inserted at index 1. And so, that's the last available position. We then compare 2 to its parent, which is 9. And since 2 is less than 9, we swap. Inserting 7 now. 7 inserted at index 2. Since that's the last available position, we compare the 7 to its parent. And since 7 is larger than its parent, there's no need to swap. Now, we insert 3. So it gets inserted at index 3. And that's the last available position. And since the 3 is less than 9, we swap it. Moving on, let's insert 6. Now, 6 inserted at index 4. That's the last available position. Then, we compare it to its parent again. And since 6 is larger than its parent, there's no need to swap. Now, inserting our last data, which is 5. 5 gets inserted at index 5. 5 is less than its parent, and then we swap. Heap sort is a comparison-based sorting algorithm that uses a binary heap, usually a minimum heap, to efficiently sort an array of numbers. So that's the pretty much basics of insertion for minimum heap. It's literally the same thing for our maximum heap, except when you compare child data to the parent, you only swap if the child data is greater than the parents.
I am Ernest Dave De Los Reyes, and this is the explained the code of insertion sort in this line for int for loop interface over the arrays starting from the second element. In this section or in this line, in temp, this line stores the current element for the arrays in a temporary variable called temp. And in this line, int j stores the index of the various elements of, of the array in a temporary variable called j. This while loop iterates over the sorted part of the arrays. Starting from the previous element, the loop terminates when it reaches the beginning of the arrays or when it encounters an element that is smaller than a temp variable. This line shifts the element to at index j variable to the right, and this j minus decrement the index variable j. This array line inserts the element of the temp variable at index j plus 1. Let's try to run the problem or the code.